Hello everyone, I am Dev Pateria from International Institute of Professional Studies, DAVV, University in Indore, and today we are gonna see the solutions of first internal set A of computer oriented numerical methods, and we are going to look into the solutions. This whole assignment was guided by Dr. Shaligram Prajapat, so thanks sir. Now let's get to the first question. The very first question is find the cube root of 12 using Newton-Raphson method, correct up to 4 places of decimal. Okay, so here is the image of solution, and if it is not clearly मतलब साफ साफ नहीं दिख रही है अगर आपको तो then you can just ask me in the comment. I will provide you with the notes. Okay, so very first we will take the value of x cube equals to 12 because we have to find the cube root of 12. Then we can also write the equation as x cube minus 12 is equals to 0. Then we will define it as a function. So fx is equals to x cube minus 12. Then after using the differentiation on it, we will get f dash x value, which is gonna be 3x square. Now, after applying the Newton-Raphson formula and initial guess x naught equals to 2, means we will taking the value of x0, which is gonna be equal to 2, and Newton-Raphson formula. What is Newton-Raphson formula? It is here. This is actually Newton-Raphson formula. This one. Okay. So now we will taking x naught equals to 2, and now we will solving this formula, which is xn plus 1 is equals to xn minus f xn divided by f dash xn. Okay, so x1, for the x1, like now we are taking the value of n to 1 and gonna find different values for different iterations of x. Okay, so firstly for x1 we get 2 minus x naught cube minus 12 divided by 3x square. After solving the whole equation, we will get the value of 2.3333. Now we will go to the second iteration, which is gonna be x2 equals to 2.3333 minus 2.3333 cube minus 12 upon 3 into 2.3333 square. After solving this specific part, I mean this part, we are solving this part right here to its exact value. So we will get its value 0.0430. Now after subtracting the value of 0.0430 from 2.3333, we will get 2.2903, and this is the square cube root of 12 by Newton-Raphson method up to 4 places of decimal. Now next question, write an algorithm, flowchart, C, Python, or MATLAB program for finding square roots of 12 using fixed point iteration method. So we will be writing a Python program. So initially we will start with defining a function, square root fixed point, sqrt, fixed point iteration, and we will sending the argument number in it. Then we will take a guess equals to number divided by 2.0, which is gonna become our initial guess. Now for in range 10, guess equals to 0.5 into guess plus number divided by guess, fixed point iteration formula as written here. This is the formula for fixed point iteration. Okay, now after that we will return the guess. Then if condition, name equals to main, number to find the square root, we need to find the square root of 12, right? So we will take it as a 12. Then square root is equals to square root sqrt fixed point iteration, number to find the square root. Okay, then we will print the square root of number to find square root is approximately. So this is the whole program, and you can run this on your different compilers or environments. This will give you the output, and this is accurate program. And now for the next and final question, we have give the output of Gauss-Jordan algorithm for this specific matrix. Let me just We have a 4 by 5 matrix here, and we have to give output by using Gauss-Jordan's algorithm. So this the working rule, this is the working rule here. This whole is a working rule of Gauss-Jordan algorithm. So very first we will start with step setup. So first one is setup. Begin with the augmented matrix representing the system of linear equations or the matrix to be inverted. Forward elimination, make the leading entries in each column equal to 1 and eliminate other entries in the same column. Back substitution, further reduce the matrix to its reduced row echelon from RREF, making all entries above and below leading to ones equals to 0. Solution extraction or inverse calculation, read the matrix directly from the RREF matrix. So what is basically Gauss-Jordan's method is nothing but we have to make a upper triangular matrix and then use the reverse substitution to find the values of different variables. Okay, so very first we will be seeing a question, this one. Also I have this in my copy, so I will be explaining for my notes. So basically we will be there, this is the matrix as shown in the previous slide. The values of matrix are 10, minus 6, 3, 5, minus 7, 8, 1, minus 9, 3, minus 1, 4, minus 2, 5, minus 4, 11, 4, 6, 5, 2, 7. So we just apply the following row transformations, elementary row transformations, and converting this whole matrix into this one. After this we will do the same. We will apply these transformations and making this, then we will apply this one and converting this matrix into this. Then we will continuously do repeat these steps iteratively. Then finally when after we make the whole upper and lower triangle, means the diagonal values are gonna be 1 and other values, all the other values are gonna be zeros as shown in the following matrix. Then we can just simply compare the variables with the answers and we will get our answers. Here after performing following rows and transformations, we will get the value of W equals to minus 1.209, value of X equals to minus 1.548, Y's value minus 3.077 and Z's value 1.433. And